part of, we are going to discuss the part of atomic structure. Okay, atomic structure is in progress already. ଆମେ ପୂର୍ବରୁ atomic structure କିଛି discuss କରିଛେ. So in today's class, we'll discuss Bohr's atomic model and the applications of Bohr's atomic model, then the dual nature of matter. Okay. So first we are going to discuss the Bohr's atomic model. But before going to discuss the Bohr's atomic model, we should know what is the background of Bohr's atomic model. Why the Bohr's atomic model came into picture? What is the need of Bohr's atomic model? So prior to Bohr's atomic model, we have already discussed two models of atom. One is Thomson's atomic model and another is Rutherford's atomic model, right? So one is Thomson's atomic model and another is Rutherford's atomic model. So what are the limitations of Thomson and Rutherford, so that there is a need of Bohr's atomic model? Jodi Thomson और Rutherford रो किसी limitation न था, right? Thomson और Rutherford रो किसी limitation न था, then we should not discuss or there should not be any further model. So Bohr's atomic model discuss होच माने there are some limitations present in Thomson's atomic model as well as in Rutherford's atomic model. What is the biggest limitation of Thomson's atomic model? Just I am going to recap the concepts. The biggest limitation of Thomson's atomic model is it could not distinguish between the presence of positive and negative charges, or it could not draw the boundary between the positive and negative charges. That is the major limitation. So that limitation has been removed by Rutherford's atomic model. Jote Rutherford's atomic model kon kahitila na atom is divided into two parts. One is nucleus, which is consisting of the positive charge, and outside the nucleus negative charges are there. So that is the Rutherford's atomic model. But again, what is the limit? What are the limitations of Rutherford's atomic model? So Rutherford atomic model major two limitations are there. First limitation is it could not arrange the electrons around the nucleus properly. It could not arrange the electrons around the nucleus properly. That means whether all the electrons are revolving in a single shell or single circular path or in multiple circular paths. That is the first. Second limitation, it could not explain the stability of atom. So what is the meaning of stability of atom? According to Rutherford's atomic model, electrons are revolving around the nucleus due to the force of attraction of the nucleus on the electron. Again repeating, according to Rutherford, the electrons are revolving around the nucleus due to the force of attraction of the nucleus on the electron. Tamane nucleus electron ko attract karuchi. For that reason, the electrons are revolving around the nucleus. But Clark Maxwell tak explain kon karthile. Now, if any charged object is revolving under the influence of another charged object, if any charged object is revolving under the influence of another charged object, then the revolving particle must emit energy continuously. So if it would happen to the atom, then electron continuously energy release kariba katha. If electron will release energy continuously, then it will come closer to the nucleus, and by following the spiral path, so this is the nucleus. This is nucleus. So this is the electron. By following the spiral path, it will drop into the nucleus, and this process will take some fraction of a second. So if electron will drop into the nucleus, then there is a question mark for the stability of the atom, or atom should not be stable. But we know atoms are stable. That means the assumption that was taken by Rutherford's atomic model, that is not correct. So there are two major limitations of Rutherford's atomic model that leads to the the development of Bohr's atomic model. So first limitation, the arrangement of electrons around the nucleus, how the electrons are arranged around the nucleus. Second limitation, which force is governing the revolving of electron. Which force is governing the revolving of electron. Okay, so these are the two major limitations of Rutherford-Sartre model. So that is the background of development of Bohr's atomic model. Now we are going to discuss Bohr's atomic model. So in Bohr's atomic model, there are several postulates. We are going to discuss one by one. So first, the postulate is electrons are revolving. Electrons are revolving around the nucleus in concentric circular paths known as shell or orbit. Okay. Electrons are revolving around the nucleus in concentric circular paths known as shell or orbit. This is very first postulate. Second postulate, these are numbered as 1, 2, 3, 4 from the nucleus and are designated as KL capital KLMN respectively. This is the second postulate. That means, suppose this is the nucleus. So the concentric circular paths present around the nucleus is, so it can be named as or numbered as 1, 2, 3, 4 and designations are KL, MN. So quickly note down, friends. So these are numbered as 1, 2, 3, 4 starting from the nucleus and designated as KLMN. I think all of you are writing. Okay. Now the next is okay, all of you are written. Now the next one is these are the designations. Now the question is whether all the shells or all the orbits are consisting of equal number of electrons or different number of electrons are there. Whether all the shells accommodate the same number of electrons or different number of electrons. So, right, these are shells are represented as n, the possible values of n are 1 to infinity. So, how many shells are present around the nucleus? The infinite number of shells are there. Okay, but till date, maximum 118 electrons are present in any atom. So, in order to accommodate 118 electrons, how many shells are needed? Maximum 7 shells are needed. Okay, but theoretical theoretical ground state that is normal energy state. So, number of electrons, number of shells are 1 to 7. But in excited state, the electrons can jump into the cell number infinity. Okay, any higher cell. So that we are going to discuss. Up to 3, it is clear. Then come to 4, maximum number of electrons present in a cell is 2n square, where n is cell number. So in any cell, how many maximum number of electrons can be there? Now 2n square. Okay, n is 1. So that they may first cell the cure. 2 into 1 square, that is 2. Second cell, 2 into 2 square, 8. Third cell, 2 into 3 square, 18. Fourth cell, 2 into 4 square, that is 32. That means we can say that third cell can accommodate a maximum of 18 electrons. But it is not always necessary that 18 electrons will be present in the third cell. But it should not exceed 18. It can be less than 18. So that is the case. Next, the fifth one. ଆମେ ଯଦି ଦେଖିବା ଗୋଟେ particular cell, suppose ଆମେ କହିବା in second cell one electron is revolving. So as long as the electron is present in the second cell, then there will be no loss or gain of energy. So cells are known as the energy levels. Cells are known as the energy levels. So that means as long as electrons are revolving in a cell, there is no loss or gain of energy. So cells are named as energy levels. So cells are named as energy levels. Is that clear? Okay. So this is the case. That means जेपर्यंत गोटे पर्टिकुलर सेल रे इलेक्ट्रॉन रिवॉल्व होउथिबो ना एनर्जी किछि लॉस होबो ना एनर्जी किछि गेन होबो सेतिबे ताको जे एनर्जी लेवल्स. नाउ द क्वेश्चन इज कोन इलेक्ट्रॉन रो केबे भी एनर्जी लॉस होबो कि इलेक्ट्रॉन केबे एनर्जी किछि अब्जॉर्ब करि परिबो? यस, इलेक्ट्रॉन कैन डू दैट. बुझ पर स्टूडेंट्स, ता माने इलेक्ट्रॉन कैन रिलीज एनर्जी, इलेक्ट्रॉन कैन अब्जॉर्ब एनर्जी. यदि एनर्जी रिलीज होबो then what will happen? Then the energy absorbed hobo, then what will happen? Okay. So I mean, with increase in cell number, energy increases. Ta mane cell number 1 is associated with the least energy, and infinity, the electron present at infinity is associated with the highest energy. Right? Ta mane electron cell number 1 lowest energy. ଯଦି cell number 1 रे किछि energy absorb करे गोटे electron, then that will jump into the higher cell. So which higher cell? It depend करिवा केते energy से absorb करूछि. So जेतिक energy absorb करिवो, accordingly it will jump to the higher cell. ताले हम कोन कहि परिबा? Next ना electrons can change the cell by either absorbing or emitting energy. So that means when the electron jumps from lower cell to higher cell, lower to higher, that means lesser energy, lower energy state to higher energy state. Higher cell energy is absorbed. Similarly, when the electron jumps from higher cell to lower cell, energy is released. Okay, so mathematically we can write delta E equal to E2 minus E1, that is equal to H nu. So what is E2? E2 is energy of higher cell, U1 is energy of lower cell. Okay, quickly note down, students. Then we'll go to the last postulate of Bohr static model. Up to this, we have discussed what is the arrangement of electron and how the electron can change the shell. So all these things are summarized here. Okay, all these things are summarized here. Quickly note down. So next one we are going to discuss, that means still one limitation is there. So what is that limitation? The limitation is how the electrons are how the electrons are um, revolving around the nucleus, or which force is governing the revolving of the electrons. So that is the last one. So according to Bohr's atom model, only those electrons are revolving around the nucleus for which angular momentum angular momentum is the integral multiple of h by 2 pi. Integral multiple of h by 2 pi. So we know the formula of momentum is m into v. So angular momentum is mvr. Okay, mass into speed into radius. Integral multiple nh upon 2 pi. So this is the formula. So that means according to Bohr's atom model, she कौन कहले ना all the electrons cannot revolve around the nucleus. So electron को nucleus रो surrounding रे revolve करिया ପାଇଁ किछि specific criteria condition fulfill करिया पड़िबो. So what is that criteria condition? The criteria is the angular momentum of the electron must be the integral multiple of h by 2 pi. Angular momentum of the electron must be the integral multiple of h by 2 pi. ता माने n stands for the cell number. So suppose गोटे electron cell number 3 रे revolve करिवो. Then so mass of the m stands for mass of the electron, v speed of the electron, r radius of orbit, n cell number. Now I think all of you got this. So यदि ये सब conditions से fulfill करथिबो, then only the electron can revolve around the nucleus. Okay, then only the electron can revolve around the nucleus. So product of mass, the speed and the radius of the orbit. In which orbit the electron is present, radius of the orbit, it must be equal to nh upon 2 pi. Okay, so these are the, say, whether it is correct or not, that we will discuss later. But these are the postulates given by Bohr's atom model. Okay, these are the postulates given by Bohr's atom model. So then first Thomson's atom model, then Rutherford. Now this is Bohr. After Bohr's atom model, there was another model, that is Sommerfeld Bohr atom model. That has also certain limitations. Then the last one is quantum mechanical model, जोटा को हमें आज डेट रे more appropriate model बोली आको consider करूचे. So quantum mechanical model. So that is supposed to be the most appropriate one till date. Okay. So in future, maybe because theoretical science means there might be some modification. So we cannot say, but till date we are thinking that a quantum mechanical model is the best model which describes the structure of the atom. So quantum mechanical model हमें आगो को पढ़ियो. So now before going to the application of this Bohr's atom model, so we'll discuss the limitations of Bohr's atom model. Okay, limitation of Bohr atom model. So very first limitation, it is applicable for only hydrogen atom or hydrogen like ion and fails to explain for multi electron system. That means hydrogen atom consists of one electron. So the hydrogen like ion means He plus. Hydrogen like ion means He plus, lithium 2 plus. Suppose we are taking neon. Neon consists of 10 electrons. So neon 9 plus. So for all these we can apply the model. Second, what is the next limitation? The next limitation is according to this, electrons are revolving around the nucleus in constant speed in the circular path. Okay, in a circular path with constant speed. So we can measure the position because in a circular path, that means हमें radius of the circle easily measure कर परिबा. So we can measure the position and momentum of an electron simultaneously and accurately. Okay, so according to this, electrons are revolving in a particular cell with constant speed. That means position and momentum can be measured simultaneously accurately. But it is contradictory to Heisenberg uncertainty principle. हमें आगु डिस्कस करिबा. So Heisenberg uncertainty principle tells that it is impossible to measure the position and momentum. It is impossible to measure the position and momentum of any microscopic object simultaneously and accurately. Okay, of any microscopic object simultaneously and accurately. But according to this, the position of electron and momentum of electron can be measured simultaneously and accurately. So it is contradictory to the Heisenberg's uncertainty principle. Next limitation is it fails to explain Zeeman and Stark effect. Okay, it fails to explain the Zeeman and Stark effect. What is Zeeman effect? If we are taking any electromagnetic radiation and when it is passed through the magnetic field, it will be splitted into lines. Similarly, if any electromagnetic radiation is passed through electric field, it is splitted into lines. So this splitting of lines in magnetic field is known as Zeeman effect, and in electric field it is known as Stark effect. मन रखिए अपनी spark कोथरे हुए ना electricity हुए. So Stark effect that is related to electric field. Zeeman effect that is related to magnetic field. So that means according to this, it fails to explain the Zeeman effect or Stark effect. Now the question is it necessary कि जो भी हमरो theory रहिबो से सब इफेक्ट को एक्सप्लेन करि परिबो? सेट नेसेसरी नुहे. ताले एठी Zeeman effect और Stark effect रो बोर्स एटम मॉडल सहित रिलेशन कौन देखा हलो जब हम कहले electrons are jumping from one cell to another cell. So while electrons are jumping from one cell to another cell, single line spectra is obtained. I mean discuss करे just after hydrogen spectra, single line spectra was obtained. But when those line spectra were passing through the electric and magnetic field, so those are splitted into different lines. ताले splitting होतला इलेक्ट्रिक फील्ड रे जोटा का स्टार इफेक्ट कहउचे, मैग्नेटिक फील्ड रे जोटा में जीवन इफेक्ट कहउचे. So why does this splitting happens? Why does this splitting happen? So it could not be explained by the Bohr's atom model. Okay, so it is another limitation. Up to this, any doubt, student? If any doubt, then raise your hand or write down in the chat box. Okay, 1 2. Okay, angular momentum means okay. So limitation ro 1 and 2 explain kar. Okay, see, I'm going to explain it again. This Bohr-Sati model is applicable for single electron system. तामाने हमें आगु देखिबा ना Bohr-Sati model जब स्पेक्ट्रा हाइड्रोजन स्पेक्ट्रा देखिबा और radius of orbit or speed of electron in the orbit or the energy of the orbit or energy of electron present in the orbit ये सब जिन हमें जो explain करिबा कि derive करिबा so all are applicable for the hydrogen atom or single electron system. Hydrogen like ion जोटा कहउचे single electron system. जोटा हम कहले He plus lithium 2 plus neon 9 plus आ ପାଇଁ applicable. ଯଦି multi electron system ଦେଖିବା ଆମେ ଯଦି helium atom नबा कि lithium atom नबा then this model is not applicable. Okay. अच्छा second होची कोन ना जेम कहले there is one concept or principle that is Heisenberg's uncertainty principle. Heisenberg uncertainty principle कोन explain करछि now it is impossible to measure the position. It is impossible to measure the position and momentum of any microscopic object like atom, electron, proton, किसी भी microscopic object simultaneously and accurately. Okay, simultaneously and accurately. So it is impossible to measure the positional momentum of any electron simultaneously and accurately. But I mean, now according to Bohr-Sati model, electrons are revolving in constant circular path or fixed circular path with constant speed. ଯଦି ଫିକ୍ସ ସର୍କୁଲାର ପାଥ ହେଲା ତାହେଲେ ଆମେ ତା ରେଡିୟସ୍ କୁ ମେଜର କରିପାରିବା ତାହେଲେ ପୋଜିସନ ବି ମେଜର କରିପାରିବା ଆକୁରେଟଲି ଆଉ କନଷ୍ଟାଣ୍ଟ ଯଦି ସ୍ପିଡ ଅଛି ସୋ ମାସ୍ ତ କେବେ ଚେଞ୍ଜ ହବନି ମୋମେଣ୍ଟମ ଇଜ ମାସ୍ ଇନଟୁ ଭେଲୋସିଟି ସୋ ମାସ୍ ଯଦି କନଷ୍ଟାଣ୍ଟ ରହିଲା ସ୍ପିଡ ଯଦି କନଷ୍ଟାଣ୍ଟ ରହିଲା ମୋମେଣ୍ଟମ ବି ସବୁବେଳେ କନଷ୍ଟାଣ୍ଟ ରହିବ ତାମାନେ ମୋମେଣ୍ଟମ କୁ ଆମେ ଆକୁରେଟଲି ମେଜର କରିପାରିବା ତାହେଲେ ଏଟା କ'ଣ ହେଲା ଇଟ ଇଜ ଦ ଲିମିଟେସନ ଟୁ ଦ ହାଇଜେନବର୍ଗ's uncertainty principle. Okay, so next एटा रहला हम जोटा थर्ड कहले फेल्स टू एक्सप्लेन द जीमान स्टार इफेक्ट जोटा हमें देखले जो स्पेक्ट्रा हबो हमें देख आप पर जस्ट डिस्कस करिवा सो हाइड्रोजन स्पेक्ट्रा हबो सो हाइड्रोजन स्पेक्ट्रा रो जो सिंगल लाइन बनिबो सो इफ we are passing those single lines in the electric and magnetic field then those lines will be splitted into different lines. So why does this splitting happen? It could not be explained by the uh, Bohr's atomic model. So, is it clear, students? Those have asked the question. Limitation 3. Okay, ever discuss kali. Deepak Maji, is it clear? I think the last student, Barihar, I think it is clear. I have explained it again. Okay, now next is next limitation. जेंदे हम कहले angular momentum कि स्टूडेंट जन पचारले angular momentum माने व्हाट इज द फार्मूला ऑफ momentum है मास इनटू स्पीड और मास इनटू वेलोसिटी सो ता सहित जदि हम रेडियस टर्म को मल्टीप्लाई कर दबा सो momentum सहित जदि हम रेडियस टर्म को मल्टीप्लाई करिवा सो दैट विल बी angular momentum so m into v into r that is angular momentum so angular momentum is the integral multiple जोटा हम कहले mvr equal to nh upon 2 pi जो formula mvr equal to nh upon 2 pi asila ko okay what is the derivation of this formula so he could not derive the formula mvr equal to nh upon 2 pi और हम तो कहि परिबा he could not explain the concept of quantization of angular momentum. He could not explain the concept of quantization of angular momentum. Okay, so these are the limitations of Bohr's atomic model. So a limitation by हमको next हमको model आस्तिला Sommerfeld तापर पुने आस्तिला quantum mechanical model. So any doubts up to this? Ask, else we'll move to the next, that is hydrogen spectra. Is it clear to all of you? Okay, so I think it is clear to all of you. Now, next is hydrogen spectra. Hydrogen spectra. So, what is hydrogen spectra and how it is related to Bohr's atomic model that we are going to discuss. From then, in nature, hydrogen is present in the form of H2. Hydrogen is present in the form of H2 in nature. Okay. So the H2 form hochi. So if we are giving energy to H2, so that will be converted to hydrogen atoms because by observing bond dissociation enthalpy, so the bond will be broken. So hydrogen molecule will be converted to the hydrogen atoms. So H2 will be converted to two hydrogen atoms. Now, still, if we are supplying the source of energy, then the electrons from hydrogen. So originally hydrogen means that is only one electron. So that electron must be present in the first cell. That electron must be present in the first cell. So by observing energy, now apply the postulate that is this uh, hmm, when the electron jumps from lower cell to higher cell, energy is absorbed, or by observing energy, electron can jump from lower cell to higher cell. So here, electron was present in cell number 1. So by observing energy, it will jump to higher cell. So which cell go? It can be second cell, it can be third cell, it can be even infinity cell. So now by observing energy, electrons are promoted to the all higher cells. Go now starting from cell number 2 to cell number infinity. So we can see the electrons are present in different higher cells. Okay, so we can number them 1, 2, 3, 4, all possible. Let it be infinity. So electrons are now present in all possible cells by observing energy which was provided here. When the energy source will be stopped, कारण एनर्जी आम सप्लाई करें स्टप भी कर एनर्जी सोर्स आम स्टप करदे तो कौन हम ना इलेक्ट्रॉन्स आम जाने एवरीथिंग इज स्टेबल एट द ग्राउंड स्टेट एवरीथिंग इज स्टेबल एट द ग्राउंड स्टेट मीन्स दैट इज लोएस्ट पॉसिबल एनर्जी स्टेट so similarly electron is also stable at the ground state or lowest possible energy state. So lowest possible energy state is nothing but cell number 1. So electron code stable रहिबो cell number 1 रे stable रहिबो. But electrons are now present in all higher cells. So those will try to come back to the ground state, that is cell number 1. So cell number 1 जेतले आसीबे return करिवे, so केमती return करिवे? So maybe the electrons will directly jump from the any higher cell, maybe fifth, maybe sixth, maybe infinity, to the cell number 1 directly, or एमती हेई परिबो जे cell number 6 रे अछि, it can jump to cell number 5, then cell number 4, then cell number 3, then 2, then 1. So all possibilities are here. बुझिपार स्टूडेंट, all possibilities are here. यदि सब possibility हेई परिबो, so केमते जानिबा ना, that depends how much energy is being released. So जति energy release होबो सेही हिसाब से cell decide होबो. ताले so electron is present, आमे कहले cell number infinity. So cell number infinity to cell number 1, or the 7th cell to cell number 1, or 6th cell to cell number 1, means all the electrons are coming to the cell number 1. So this way it makes one series. Yes or no? This way it makes one series. Similarly, all the electrons from the higher cell can come to the cell number 2. This you can draw, or cell number 3. You can draw along with me, or cell number 4, or cell number 5, or cell number 6. So by this way, a series of lines are obtained. By this way, a series of lines are obtained. So what is there any specific name to the series? Yes, specific names are there. So all the cells, all the electrons jumping to cell number 1, that consists of the series known as Lyman series. So cell number 2, that is Balmer series. Cell number 3, that is Bastian series. This is bracket. This is Font series. And this is Humphrey series. Take 2 minutes and note down. Cell number 1, Lyman. Cell number 2, Balmer. Cell number 3, Bastian. Cell number 4, bracket. Cell number 5, Font series. P is silent. And cell number 6, Humphrey series. Quickly note down, then we'll discuss further. I have all of our writing. Okay. Now, these lines are corresponding in different region. Any doubts, friend, up to this? Write in the chat box. If any doubt, finished. Okay, good. So, Lyman series is coming under UV region. Balmer series is visible region, and all other are coming under infrared region. Again repeating, Lyman series, ultraviolet region, then Balmer series, visual region, and all others are coming under IR region, that is infrared region. Okay. Achha. Now we are going to discuss the next. So आम एत सब जिन जो डिस्कस करुचे, राइट? सो कौन टाइम डिस्कस करुचे? सो ऑब्वियसली आमको किसी कैलकुलेशन करियार अछि. सो कैलकुलेशन कौन करियार अछि ना फर्स्ट हैला नंबर ऑफ distinct lines. Suppose but electron present is cell number 6 रे. So it is coming to cell number 2. Cell number 6 to cell number 2. How many distinct lines are obtained? So I am in general 6 to 2, 6 to 3, then 6 to 4, 6 to 5, then 5 to 2, 5 to 3. So this way we can count. But obviously that will take time. So छोटा अच्छी but 10 ରୁ 1 then you cannot count in a short span of time. So it will take time. So there is a formula to find the number of distinct lines. So that formula is nothing but n2 minus n1 into n2 minus n1 plus 1 divided by 2. So here n2 is higher shell, N1 is lower shell. Okay, so suppose we are saying higher shell, that is N2 is 5 and it is coming to the ground state. Ground state means N1 is 1. So number of lines, that is 5 minus 1 into 5 minus 1 plus 1 divided by 2. So 4 into 5 by 2, that is 10 lines. That is 10 lines. So number of distinct lines are 10. So this is one formula. Next, we'll discuss what is alpha line, beta line, and gamma line. Alpha line or first line. Alpha line or first line. Friend, if you'll observe in Lyman series, so which radiation is coming or which transition is coming from the nearest cell. So in Lyman series, it is nothing but 2 to 1. The transition that is 2 to 1, that is the nearest one. So that's why we can alpha line in Lyman series, or that is corresponding to first line. So alpha line means the transition of electron from the nearest cell. From the nearest cell. Okay. So the Balmer series kaiba. So Balmer series alpha line means it is coming to 2, cell number 2. So nearest cell ki 3. So 3 to 2, that is alpha line. Then come to beta line or second line. So beta line or second line kon kaiba? A transition from nearest cell. So the Lyman series re beta line is 3 to 1. In Lyman series, beta line is 3 to 1. Then come to gamma line or third line. So that is next to beta line. So Lyman series is the gamma line kaiba, that is 4 to 1. So I think alpha line, beta line, gamma line. So it is clear. So जो भी series देइथिबो, suppose font series देइछि, font series alpha line कोन, beta line कोन, और gamma line कोन, तमे easily कहि परिबो. Okay. So I think it is clear. Any doubt up to this? Student, raise your hand if any doubt or write in the chat box. If any doubt, student, write in the chat box. Tadi हमें समस्त microphone unmute कर दो, ताले noise आसो class रे. Okay. यदि किसी तमर doubt अच्छे, then write in the chat box. So next is any doubt up to this, student? No. Okay, good. So next one is how to find the wave number. So that is the Rydberg's equation. That is the Rydberg's equation. So what is Rydberg's equation? It is used to calculate. It is used to calculate the wave number. It is used to calculate the wave number. So that is 1 by lambda equal to RH Z square 1 upon N1 square minus 1 upon N2 square. RH into Z square into 1 upon N1 square minus 1 upon N2 square. So what is RH? Rydberg's constant. So its value is 109,677 centimeter inverse, or you can write 1.1 into 10 to the 5 centimeter inverse. Okay. Then Z is atomic number, N1 is lower cell, N2 is higher cell. Okay. N1 is lower cell and N2 is higher cell. Student quickly note down. Then we'll discuss one or two more concepts, then numericals. Okay. Next come to series limit. Next come to series limit. What is the meaning of series limit? Series limit means, what is limit? What is the meaning of limit? What is the meaning of limit? Limit means it is the range. Okay. So it is the range between the minimum to maximum. Range between minimum to maximum. So if you'll see in the Lyman series, अच्छा एठी हमें सीरीज लिमिट कहाँ रेस्पेक्ट रे कैलकुलेट करिवे? एठी हमें सीरीज लिमिट कहाँ रेस्पेक्ट रे कैलकुलेट करिवे? So we can calculate the series limit with respect to the energy or wavelength. We can calculate the series limit with respect to energy or wavelength. So how to find? Now, so it is the range between highest and lowest. We know that energy associated with the cell number 1 is the least and cell number infinity is the highest. That means with increase in cell number, energy increases. With increase in cell number, energy increases. Tale, cell number 1 is associated with lowest energy, n equal to 1. Highest energy, n equal to infinity. Lowest energy, n equal to 1. Highest energy, n equal to infinity. Is that clear to all of you? So now see, I'm at home. Now, energy limit. Limit energy. Okay, or energy limit. The Lyman series nova. In Lyman series, E maximum केतोल होबो जेतोले n2 is infinity and n1 is 1, and when the minimum energy when n2 is 2 and n1 is 1. Yes or no? So when the electron jumps from cell number infinity to cell number 1 in Lyman series, that will be associated with the highest energy. When the electron jumps from the second cell to cell number 1, that will be associated with the least energy. That will be associated with the least energy. Lyman series clear? Okay. So here, suppose we are taking Balmer series. In Balmer series, when there will be maximum energy, now when n2 is infinity and n1 is 2, because all the radiations falling to cell number 2, and minimum energy n2 is infinity and n1 is, sorry, minimum energy n2 is 3 and N1 is 2. N1 is 2. So maximum energy corresponds to the shortest wavelength. Minimum energy corresponds to the longest wavelength. Because we know E equal to hc by lambda. H is constant, C is also constant. So energy is inversely proportional to wavelength. So the maximum energy kaiba that corresponds to the shortest wavelength, and minimum energy kaiba that corresponds to the longest wavelength. Okay, that corresponds to longest wavelength. So up to this clear, student, series limit note कर दियो, and any doubt you can write in the chat box. Take 2 minutes and quickly note down. After this, we'll discuss some questions based on hydrogen spectra. I hope all of you are writing. Okay, friend, note करছো तो? Quick. Then write down 2 questions. Find out the number of distinct lines when electron jumps from 6th shell to the second excited state. Second, calculate E max and E minimum for the transition in the Balmer series for He plus ion. Calculate wavelength associated with beta line in the bracket series of hydrogen atom. So take some time, note down the questions, then solve. All of you make it fast. Take some time. Completed student? How many of you have completed? Okay. Only first question. Okay. Try other questions. Take 2 more minutes. Quickly try. Student, how many of you have completed? Jadi ko question તમે પઢી ન પાડશો, then write the question number so that I can read it out. Okay, second and third question. Second question is calculate E max, means the maximum energy and minimum energy for the transition in the Balmer series for He plus ion. That is second question. Third question, calculate the wavelength associated with beta line in the bracket series of hydrogen atom. Bracket series of hydrogen atom. Okay. So how many of you completed all the three? Raise your hand or write in the chat box. Okay, last 2 minutes, then we'll discuss. last 2 minutes. Last 1 minute. Make it fast. Okay. Now come to the first question. Can you write in the chat box how many of you have completed? Okay, we'll discuss. Student one answer likhicha. Good. So first question, find out the number of distinct lines when electron jumps from 6 shell to the second excited state. See, what is the ground state? Cell number 1. First excited state, cell number 2. Second excited state, cell number 3. So here N2 is 6 and N1 is 3. So number of lines equal to 6 minus 3 into 6 minus 3 plus 1 divided 2. So that is 3 into 4 by 2, that is 6. It is the answer to the first question. Ketanakar answer correct thila? Write in the chat box. How many of you did this correctly? Next come to the second question. Calculate the energy maximum and energy minimum for the transition of Balmer series of He plus. Okay. তাহলে আমি দেখি স্টুডেন্ট for E max in Balmer series N2 is infinity and N1 is 1. Sorry, Balmer series N1 is 2. So we know E equal to Hc by lambda, or H in C. What is the formula for 1 by lambda? That is RH into Z square 1 upon N1 square minus 1 upon N2 square. Hc into RH Z square 1 upon N1 square minus 1 upon N2 square. So H 6.626 into 10 to the minus. हमें यदि RH को CGS यूनिट हो जाए, better to take minus 27 into 3 into 10 to the power 10 centimeter per सब CGS number 1.1 into 10 to the 5 into Z. So which helium? So helium means Z is 2 square, that is 1 upon 2 square minus 1 upon infinity square. So while solving 6.626 into 3 into 1.1 into 10 to the power minus 27 plus 10 plus 5, 15. Now 1 by 2 square and into 2 square. Cancel out ejibo. So we can write, solve करते समझते. Now compare with your answer. So it is 6.626 into 3 into 1.1, that is 21.865 into 10 to the power minus 27 plus 15. So minus 12 or एमती लिख पारे 2.1865 into 10 to the minus 11 arc. This is E max and E minimum. For E minimum, N2 is 3 and N1 is 2. So it is E equal to HC into RH Z square 1 upon 2 square minus 1 upon 3 square. So 6.626 into 10 to the minus 27, 3 into 10 to the power 10, RH 1.1 into 10 to the power 5 into Z square, again 2 square, 1 upon 4 minus 1 upon 9. Okay. So आमे देखिबा स्टूडेंट केते आछि को ना ए फैक्टर ऑलरेडी आमे देखिजे. So this is 2.1865 into 10 to the power minus 11 into 4. ये केते आसीबो ना that is 5 by LCM ले जिबा 36. 5 by 36. So this is 9. So 5 by 9 I multiply कर दूंगा. So 2.1865 into 5 divided by 9. So that is 1.214 into 10 to the power minus 11 arc. Minus 11 arc. No down here. And compare how many of you did it correctly. Take some time and note down. Done completed. Can the answer match करथिला? Write in the chat box. Okay, now the next one is the last one. Calculate the wavelength associated with beta line in the bracket series of hydrogen atom. Beta line in the bracket series of hydrogen atom. So bracket series. So bracket series means here N1 is 4 and N2 can be 5 to infinity. Okay. So if N1 is 4, then alpha line N2 must be 5, beta line N2 must be 6. So here N2 is 6 and N1 is 4. So 1 by lambda equal to RH Z square 1 upon N1 square minus 1 upon N2 square. So here Z is 1 because hydrogen atom 1.1 into 10 to the 5 into 1 into 1 upon N1 square 1 upon 4 square minus 1 upon 6 square. 1 upon 4 square minus 1 upon 6 square. So 1.1 into 10 to the 5. So it is 1 upon 16, 1 upon 36. So 1.1 into 10 to the 5 into 20 upon 16 into 36. So this is 4, 5. So 1.1 into 5 divided by 4 into 36, 10 to the power 5. It is centimeter inverse. So now 5.5 divided by 4 divided by 36. So it is coming 0.038 into 10 to the power 5, or scientific notation 3.8 into 10 to the power 3 centimeter inverse. That is 1 by lambda. So lambda equal to 1 upon 3.8 into 10 to the 3. That is 1 upon 3.8. It is 0.263 into 10 to the power minus 3 centimeter, or 2.63 into 10 to the minus 4 centimeter. This is the answer. Right on, student? I hope all of you are writing. Over? Any doubt up to this? Okay, student. Now we are going to take the short break. So after the break, we are going to meet in the second session. So second session हम कौन discuss करेगा? Now it is related to the calculation. That is calculation based on related to calculation. से कौन? The calculation based on the radius, energy, and speed of electron. Okay, students. So log out करिया दरकार नहीं. So keep on login. ଆମେ 15 minutes ପରେ ଆଉଥରେ ଆଉଥରେ discuss କରିବା. Okay. Welcome back, students. So after the break, we are going to continue the same, that is Bohr-Sati model. So in the first half, what we have discussed? In the first half, we have discussed the let us recap the things for 1 minute. So in the first half, we have discussed the postulates of Bohr-Sati model. Okay. So after the postulate of Bohr-Sati model, then we have discussed the limitations of Bohr-Sati model. Then after the limitation, hydrogen spectra and the different lines, that is Lyman series, Balmer, Paschen, bracket, Fond, and Humphrey series. Then number of distinct lines, this formula, then alpha, beta, gamma line. Then Rydberg equation. So Rydberg equation is basically used for calculation of this wave number, calculation of wave number. So तापर हम discuss करते हैं series limit with respect to wavelength and the energy. तापर हम discuss करते हैं some numericals. Okay, so these are the things we have discussed in the first session. Now we are going to discuss the second, that is applications of the same application गोटे तो रहिला तमरो calculation of hydrogen spectra or discussion of hydrogen spectra. Our second application I am discuss kariba finding. So you can see, yes. So application of Bohr-Sati model, radius of orbit in which the electron is revolving around the nucleus. Second, energy of the orbit, then velocity or speed of electron in the orbit, frequency of electron revolving around the nucleus. Okay, so these are the things to be discussed and to derive we are going to discuss here. So the screen is clear, students? Before going to discuss, tell me whether the screen is clear and any doubt from the first session. If any doubt from the first session, then raise your hand or write in the chat box. Okay. Now we are going to discuss the remaining things. So first, you will see the energy. We are discussing the hydrogen. We are discussing the Bohr-Sati model for single electron system. Single electron system, that is hydrogen atom or hydrogen like ion. Okay, students, hydrogen atom or hydrogen like ion. Remember, for single electron system, potential energy is negative of twice kinetic energy. Okay, potential energy is twice negative of kinetic energy, and total energy, of course, it is potential energy plus kinetic energy, that is minus kinetic energy. Okay, that is minus kinetic energy, that is total energy. And another thing, remember, the one idea thibo above principle means how to arrange the electrons in subcell. So I mean, but a cell re different subcell achi SPDF, NS, NP, it agu detail discuss kariba, ND and NF. NH cell, S subcell, P subcell, D subcell, and F subcell. So this is NF has highest energy, then ND, then NP, then NS. This is for multi-electron system. Multi-electron system. But for single electron system, the energy of Ns equal to Np equal to Nd equal to Nf. The energy of Ns equal to Np equal to Nd equal to Nf. Okay, that means there is no difference in energy among the subcells belonging to a cell. There is no difference in energy among the subcell belonging to a cell. Hello? So energy difference किछि रहइबे. The reason कोन ना आमे कोन कहूचे ना energy compare करूचे. So when one electron is present in NH cell and S subcell and another is NH P subcell. So दीटा energy हम compare करते. But single electron हम energy कहाँ से compare करिबा. So I hope all of you got my point. यदि सिंगल इलेक्ट्रॉन सिस्टम अछि ताले एनर्जी हमें कहा सहित कंपेयर करिबा सेति पई कोन ना फॉर सिंगल इलेक्ट्रॉन सिस्टम देयर इज नो डिफरेंस इन एनर्जी अमंग द सबसेल्स देयर इज नो डिफरेंस इन एनर्जी अमंग द सबसेल्स हला सो एटा रहला हमरो फॉर सिंगल इलेक्ट्रॉन सिस्टम एनी डाउट स्टूडेंट अप टू दिस क्लियर टू ऑल ऑफ यू ओके डन सो नाउ you can see how to find the formula for radius of the orbit. So you can see for a system composed of two oppositely charged ions, that is ZE, you can say ZE and E. So ZE here, ZE stands for the charge of the nucleus. Z proton and E charge of proton and charge of electron both are same. So Z is the atomic number of proton or electron. So the electrostatic force of attraction is, so that is the product of the charges and square of the distance between them. So electrostatic or Coulomb's law kon kochi na the force of attraction between two charged particles is directly proportional to the product of their charges and inversely proportional to distance, the square of the distance between them. So ताको हम लिख ले कोन F equal to 1 upon 4 pi epsilon 0 JD into E upon R square. You can note down along with me. So because electron having mass m is revolving around the nucleus, so centrifugal force that is equal to mv square upon R. So one is the Coulombic force of attraction, another is the centrifugal force. So both must be equal in magnitude. Both must be equal in magnitude. So हमें कौन लिख परिवा 1 by 4 pi epsilon 0 ZE square upon R square, that is equal to mv square by R. Now we know from the postulate of Bohr's atom model, angular momentum is the integral multiple of h by 2 pi. So angular momentum mvr equal to nh upon 2 pi. mvr equal to nh upon 2 pi. So हमें देखो स्क्वायर करिबा बोथ साइड. ओके बोथ साइड स्क्वायर करिया m square v square into r square equal to n square h square divided by 4 pi square और mv square equal to हमें देखो अरेंज करिबा बोथ साइड रे अछि. सो हमें कोन करिबा देखो mv square equal to n square h square divided by, you can see, okay, so mv square equal to n square h square divided by 4 pi square m into r square or mv square by r equal to n square h square 4 pi square m r cube. So the equation did equal kariba, then 1 by 4 pi epsilon naught z e square by r square equal to n square h square 4 pi square m into r cube. और जदि हमें आपको सॉल्व करिबा r is coming n square h square into epsilon, that is divided by z e square by pi into m, or r equal to this. Okay, so z square upon n. On putting the values, we can get the this. So take 2 minutes and quickly note down. Up to this, quickly note down. A चार्टा formula derive करिबा. First eta radius, then energy, then speed, then frequency. तापर हमें किछि क्वेश्चन डिस्कस करिबा. पेन नोट डाउन करो. तो कैंसिल नोट डाउन करो स्टूडेंट. Write in the chat box how many have noted. So okay. Then complete noise, then complete करो आगे. Quick. Make it fast. Okay. So the finally by putting these values, h square, epsilon, e charge of electron, then pi and m mass of electron. So by putting these values, we'll get the expression Rn equal to 0.529 n square upon z angstrom. N square upon z angstrom. This is the formula of radius. Next, how to find the energy? How to find the energy of the electron present in the particular cell? So energy, that is total energy, we can write it is the sum of kinetic energy and potential energy. Kinetic energy half mv square, potential energy that हम discuss करते so that is minus 1 by 4 pi epsilon z e square upon r. So if you are going to solve this, you can see. So half mv square can be written as 1 upon 8 pi epsilon naught z e square by r minus 1 upon 4 pi epsilon naught z e square by r. So it will be coming finally minus 1 by 8 pi epsilon naught z e square upon r. So if you are going to put the expression for r, that is which expression? This one. R h square epsilon e square pi m z square m square upon z. So here the expression is this. So that is minus z square e4 m upon 8 epsilon square h square into n square. So en equal to बाकी सब constant अच्छे थी, variable कौन रहेगा? Z रहेगा, that is atomic number and n cell number. So it is by rearranging, it is coming minus e to the power 4 m divided by 8 epsilon square h square into z square upon n square. So ये सब z square by n square छाड़ दे बाकी सब constant अच्छी. So by putting the standard values, we can write it is minus 13.6 into z square upon n square eV, electron volt. So 1 electron volt is the charge of electron, that is 1.6 into 10 to the minus 19, that is 1.6 10 to the minus 19 joule. 1 electron volt is 1.6 into 10 to the minus 19 joule. Okay. So why the negative sign is here? The significance of negative value of energy. The energy of an electron at infinity is arbitrarily assumed to be 0. So when an electron, as a student, first note down up to this, तापरे बाकी जो नेगेटिव वैल्यू रो सिग्निफिकेंस हमें डिस्कस करबा. नोट डाउन. I hope all of you are writing. डेरिवेशन मन रख बेले बेले दरकार मेनली जेई एडवांस पे ऑलरेडी तुम फार्मूला रखले जनरली स्कूल एग्जाम और तमरो स्कूल एग्जाम और तमरो नीट एग्जाम पर्यंत हे जिवो. बट इट इज ऑलवेज एडवाइजेबल टू प्रैक्टिस द डेरिवेशन ना को फॉर्म रे केबे भी को फार्मूला पका दे पारे. Written. So if you have written, then raise your hand or write in the chat box. Then we will go to the discussion. Now, what is the significance of negative sign? You can note down significance of negative value of energy. The energy of an electron at infinity is arbitrarily assumed to be 0 when an electron moves and comes under the influence of the nucleus. It does work and spends its energy in this process. The energy of the electron decreases and it becomes less than 0. That means it acquires a negative value. So quickly note down what is the significance of negative sign. Then if you are going to rewrite or rearrange E equal to minus, you can write 21.8 into 10 to minus 12 z square upon n square, that is arc per atom. Previously कौन थिला electron volt per atom. So if that is converted into the arc value, that is another unit of energy. So it is minus 21.8 into 10 to minus 12 z square upon n square, or minus 21.8 into 10 to minus 19 z square upon n square, that is joule per atom, because 1 joule equal to 10 to the 7 or 1 org equal to 10 to the minus 7 joule. that is minus 13.6 z square of n square जो हमें already लिखी है. Okay, so these are the और final लिख परिवा minus 313.6 z square of n square किलो कैलोरी पर मोल. पर मोल हम केमती कैलकुलेट करिवा ना per mole means per atom into Avogadro's number. Per atom into Avogadro's number. Okay. Write down. I hope all of the writing. Then after this we are going to discuss some questions. So student, write the first question. If you can write if radius of Bohr first orbit of hydrogen atom is this, then radius of the second orbit of helium plus would be. Then question number 1. Then question number 3. Question number 4. 1, 3, 4. Okay, students. One, three, four. Completed, student. If you have completed, write in the chat box. 1, 3, 4. I hope all of you are doing. Last 2 minutes. Discuss question number 1, 3, 4. Make it fast. So कितना स्टूडेंट कंप्लीट कर लो 1, 3, 4. स्टूडेंट क्वेश्चन ऑफ 4 रे 20,000 जगह 2,000 देखो अच्छी द रेशियो ऑफ एनर्जी ऑफ फोटन ratio of energy of photon of 20,000 angstrom jagare make it 2,000 angstrom. 2,000 angstrom wavelength radiation to that of 4,000 angstrom radiation each. Okay. So, can student complete color? Can you write in the chat box? No one has completed. Okay, take some more time. Quick. 1, 3, 4. Question number 1, 3, 4. Can you complete color student? Okay, should we discuss? Okay, before going to discuss this session, will what are the answer keys? So question number 1, the answer key is C. Question number 3, B. Then 4 also C. Okay, students. Question number 1, C, 3B, and 3, 4 also C. 4 also C. So, अब हम question discuss करेंगे. Now come to the discussion of question number 1. In question number 1, it is given the radius of Bohr's first orbit of hydrogen atom is 0.053 nanometer. So what is the formula of Rn? Rn is 0.529. What is the formula? 0.529 n square upon z angstrom. Yes or no? You can see. Okay. R equal to formula 0.529 n square upon z angstrom. This is the formula. So angstrom. So it is given that the first orbit. So first orbit means n equal to 1 and hydrogen atom is z is also 1. So Rn is given as 0.053 nanometer. Then the radius of second orbit of, so second orbit means n equal to 2, He plus means z equal to 2. He plus means z equal to 2. So R2 equal to 0.053 into n square, that is 4 by n square by z. So that is 2 into 0.053 nanometer or 0.106 nanometer. 0.106 nanometer, the option is C. No doubt, the option is C from the option. Quick. Then we'll go to the third question. Any doubt? I hope all of you are writing. Okay, now come to question number 3. Energy of the electron in the second Bohr orbit in the hydrogen atom is minus 3.41 electron volt. So it is energy is given minus 3.41 electron volt, second Bohr orbit of hydrogen atom. So n equal to 2 and z equal to 1. Okay. So this, so what is the formula of energy? E equal to minus 13.6 z square upon n square electron volt per atom. This is the formula. Then what is asked? The energy of the electron in second Bohr orbit of He plus. So if n equal to 2, z equal to 1, then the value is this. Next, what is given? N equal to second Bohr orbit 2 and z equal to also 2. Then in this case, you can write E equal to minus 3.41 minus 3.41 into 1 upon 2 square. Kahinki n already 2 thila. So minus 3.41 divided by 4 electron volt. Okay. Minus 3.41 divided by 4 electron volt. once again into 1 upon z square, na? So it is 2 square. So that is 3.41 into 4. So it is 4, 6, so minus 13.64. So option is minus 13.62. It is the correct one. From z value the same, z value can change h, n value same achi. So z is there in the numerator. So you have to multiply the energy given with the z square, that is 2 square. Write down quickly. Then we will move to the next question, that is question number 4 जोटा मैं देख लिया. Complete. Now, question number next, that is question number 4. So question number 4 is the ratio of energy of photon of wavelength. Actually, lambda 1 देख 20,000, but you have to take 2,000, and lambda 2 is 4,000 angstrom. But it is asked the ratio of energy. So that is E1 upon E2. But we know E equal to hc by lambda. So h and c are constant. So I'm like, this is lambda 2 upon lambda 1. Yes or no? H and c will be cancelled out. Lambda 2 is 4,000. Lambda 1 is 2,000. So 2 is to 1. So the ratio is 2 is to 1 or 2. It is simple one. Okay. Friend, I hope বুঝা পড়ছে. আচ্ছা, another thing, question আছে এই concept ru ionization enthalpy. Okay, ionization enthalpy. So tame already padicho ionization enthalpy in periodic properties. Kono? Now the amount of energy required to remove an electron from the ground state to completely removed from the ground state. Then एटी बोर सर्टेनमेंट मॉडल टर्म रे देखिबा हमें कहि परिबा ग्राउंड स्टेट मींस n where the electron is present, completely means to infinity. So here n1 will be n and n2 is infinity. Okay, so write down the energy required to remove an electron completely, that is sending an electron from the existing cell to infinity. Okay, to infinity. So this is what the ionization energy means here. So now you have to solve the question. First note down, then I'll ask you to solve the question. Then solve the question number 6 and question number 7. Question number 6 and question number 7. 6 is the ionization potential for hydrogen atom is 13.6 electron volt, then wavelength of the light required for the ionization energy of hydrogen. Then 7 is the maximum wavelength of light that can excite an electron from first to third orbit of hydrogen atom. Solve these two first. Take 2-3 minutes. Solve. তারপরে আমি other question করিবা. And next you can try question number 19. 6, 7, then 19. Make it fast. 6, 7, then 19. First of all, note down the questions. If all of you are doing 6, 7, then 19. First of all, note down the questions. তারপরে আমি discuss করি. Questions noted. Doing. Then doing. How many of us solved? Write in the chat box. Make it. How many have tried, students? How many of you? Write in the chat box. କେତେ ଜଣଙ୍କ 3ଟା question complete ହେଲା? 6, 7, then 19. So I hope all of you have written the question. Now come to the answers. So question number 6, the answer key is D, 7, C, and 19, also C. Compare with your answer. Compare. Okay. Question number 6. If ionization energy for hydrogen atom is, that is 13.6 electron volt, then wavelength of light required for the ionization of hydrogen atom would be. Okay. So this is energy. So how to find the wavelength? E equal to hc by lambda. E equal to hc by lambda. So can you put 6.626 into 10 to minus 34, then 3 into 10 to 8 divided by lambda. So energy हम कौन लिखेगा 13.6 in 10 to minus 19 in 1.6 in 10 to minus 19 जो जूल हम convert करेगा. So it is 6.626 into 3 into 10 to the power minus 34 plus 8 minus 34 plus 8. So that is minus 26 by lambda, or lambda equal to 6.626 into 3 into 13.6, 1 second, into 3 into 10 to the minus 26 divided by 13.6 into 10 to the minus 19 into 1.6. Okay. So the answer कौन आसिबो? That is 91.2 nanometer. write down. तापर next question को ଯିବା. Next question number 7. जो मैंने solve करते student, just compare with your answer whether the answers are matching or not. Any doubt? If any doubt, write in the chat box. Okay. And next question number 7. So what is question number 7? The maximum wavelength of light that can excite an electron from first to third orbit of hydrogen atom is. Okay. First to third orbit hydrogen atom. So E equal to hc by lambda. So here transition is given. So hc into RH z square 1 upon n1 square minus 1 upon n2 square. एतिक एनर्जी रिलीज हो सेतिक एनर्जी ऑब्जर्व होना दरकार. बुझि परछ ना नहीं. सो हम एटी एनर्जी कैलकुलेट करिवा, दैट विल बी द सेम. सो हम एटी लिख परिवा स्टूडेंट, इट वुड बी बेटर जदि तमे h into 0 वैल्यू को मन रखि दउछ into 1.1 into 10 to the 5 hydrogen atom is given. So it is given maximum that can electron from the third orbit to first to third. Okay, 1 by 1 minus 1 by 3 square. Okay, 1 by 3 square. So 6.626 into 3 into 1.1 divided by 9 into 10 to the power minus 27 plus 15 minus 12 CGS or so हमें तो कौन लिख परिवा. तो एतिक एनर्जी रिक्वायर्ड जदि रिक्वायर्ड अछि ताले में एतिक एनर्जी को प्लस रे कहि परिवा. So this is 3 2.2 approximately. So you can say 2.2 into 1.1, that is 2.42 into 10 to minus 12 or minus 12 or sorry amethi energy calculate करछे. एठी कोन पचारछि the maximum wavelength of light that can. Okay, so this is the energy. So wavelength calculate करि परिबा. So lambda हमें एमती calculate करिबा, energy calculate न करिके 1 by lambda equal to RH z square 1 upon n1 square minus 1 upon n2 square. So 1.1 into 10 to the 5 into 1 upon 1 square minus 1 upon 3 square. So अपन लिख परिवा 1.1 into 10 to the 5 into, that is 9 minus 1 upon 9, that is 8 upon 9. So lambda equal to 9 upon 8 into 1.1 into 10 to the power minus 5 meter. So हम आगे solve करिवा 9 upon 8.8, that is 1.022 into 10 to minus 5 meter or 1022 into 10 to minus 8 minus nanometer. Okay, so rest you know. Visible no? Okay. So clear? Clear? Okay, last question, students. Last question. So the question number 19 that I told you, if the series limit of wavelength of Lyman series for the hydrogen atom is 912 angstrom. So question number 19, that is lambda is 912 angstrom. Then series limit of wavelength for the Balmer series for the hydrogen atom. Okay. So if it is given series limit of the Lyman series, so we know 1 by lambda equal to RH. So hydrogen atom, so no need to write Z. 1 upon Balmer series, 1 square minus 1 upon n square. So it is given as 912 angstrom. And for Balmer series, it will be 1 by lambda equal to RH 1 upon 2 square minus 1 upon n square. So that means you have to multiply it with 1 by 4. Then you can write the answer. Okay. 1 by 4. Then lambda है कौन होगा ना 4 into this angstrom. कारण आमगे reciprocal नवा पड़िबो 4 into 912 angstrom. This is the answer. No doubt. After this, we'll go to the next one. After this, clear, students? Is it clear? Okay. Next. Next is the discussion of next is the discussion of uh, energy discuss કરી છે and radius also discuss કરી છે, then speed and the frequency. So we know from the Bohr-Satin model mvr equal to nh upon 2 pi. From the Bohr-Satin model mvr equal to nh upon 2 pi. So v equal to nh upon 2 pi m into r. V equal to nh upon 2 pi m into r. Okay. So on putting the value of r, so r value में put करियो, r value कौन? Already हमें जानचे the value of r is this h square epsilon e square pi m n square by z. N square by z. Okay. So if you are going to put the value, it will become n into h 4. This is pi m z square e square this. So by putting the values e square 2 epsilon h z into n, so e square 2 epsilon h constant, so it will be 2.18 into 10 to the power 6 z upon n meter per second, or 10 to the 8 z upon n centimeter per second. Centimeter per second. So this is the formula for the speed of the electron. 2.18 or 2.188 नहीं करियो, 2.188 into 10 to the power 6 z upon n meter per second. The frequency कौन? The number of revolutions per second in nth orbit. Number of revolutions per second in nth orbit. That is Vn upon 2 pi Rn. Vn upon 2 pi Rn. Okay. So this is the formula. I mean, frequency means repetition. So number of revolutions per second in nth orbit. So the speed is Vn and the circumference. आपको हम लिख रहे हैं speed upon circumference. Speed is Vn, circumference is 2 pi Rn. So theta को divide कर ले, you will get this answer. Okay. Now we are going to discuss some questions. Turn right to one or two question. What is the ratio of energy of the third Bohr orbit of He plus to second Bohr orbit of hydrogen. Next, an object observes a wavelength of 600 angstrom and re-emits into 2 if the first is 3 times greater than second, then find out lambda 1 and lambda 2. Lambda 1 and lambda 2. Next, if speed of electron in the first Bohr orbit of lithium 2 plus is x, then calculate speed of electron in the second Bohr orbit of beryllium 3 plus. Then calculate second Bohr or speed of electron in the second Bohr orbit of beryllium 3 plus. Solve. Write down. I hope all of you are doing. Make it fast. How many of you have completed? Keep on trying. Today discuss, students. How many of you have completed? Last 2 minutes, then we'll discuss. Last 2 minutes. Try. Okay. Now, student. What is the ratio of energy of the third Bohr orbit of helium plus to the second Bohr orbit of hydrogen? So E He plus divided by E helium. So we know the formula of energy is 13.6 Z square Z1 square by N1 square whole divided by 13.6 Z2 square by N2 square. So 13.6 cancel. So Z for helium is 2. 2 square, that is 4 divided by third Bohr orbit 9 whole divided by Z is 1 to the second Bohr orbit, that is 4 square, 2 square. 2 square means 4. So you can write 4 by 9 into 4, that is 16 is to 9. Question number 1. Then question number 2. So question number 2, first note down, student, question number 1. Then we'll move to question number 2. Noted? Okay. Now come to question number 2. An object absorbs a wavelength of 600 angstrom. Okay. So lambda is 600 angstrom and re-emits into 2. The first is 3 times greater than the second. Lambda 1 is 3 into lambda 2. Lambda 1 is 3 into lambda 2. Right? Friend, remember, energy is additive in nature. Not the wavelength. Energy is additive in nature, not the wavelength. ताମାନେ ଏମିତି କହିପାରିବା E equal to E1 plus E2 or Hc by lambda equal to Hc by lambda 1 plus Hc by lambda 2 or 1 by lambda equal to 1 by lambda 1 plus 1 by lambda 2. 1 by lambda 2. So 1 by lambda, that is 600. So it is given lambda 1 is 3 lambda 2. So at the place of lambda 1, we can write 3 lambda 2 plus 1 by lambda 2. So I have LCM number 3 lambda 2. So 3 lambda 2, that is 1 plus 3, that is 4 by 3 lambda 2. So you can write 4 by 3 1 upon lambda 2. So lambda 2 is 4 by 3 into 600. So that is 800 angstrom. So lambda 1, that is 3, lambda 2, so 2400 angstrom. फ्रेंड मन कहता एनर्जी को हम ऐड कर परिबा E इक्वल टू E1 प्लस E2 प्लस E3 जतरे भी एनर्जी थिबो बट वेवलेंथ को हम ऐड कर परिबा. आई थिंक इट इज क्लियर. नोट डाउन. मेक इट फास्ट. Then we'll go to the last question. Any doubt, student, in question number 1 and 2? If any doubt, write in the chat box. Okay, so one student has written to send the questions. Okay, I will send it to DHSC. So तमें तमर जे कॉलेज रे कोऑर्डिनेटर अछंती कोऑर्डिनेटर सर को कहबो से क्वेश्चन चाहिले कलेक्ट कर परिबे. ओके. So third question, if the speed of electron in the first Bohr orbit of lithium 2 plus is x, then calculate speed of electron in the second Bohr orbit of beryllium 2 plus. So what is the formula for speed of electron? Vn equal to 2.188 into Z upon n. 1 second. 88 into 10 to the power 6 Z upon n meter per second. Okay, this is the formula 2.188 10 to the 6 Z upon Fn. So it is given speed of electron in the Bohr orbit, first Bohr orbit of lithium is x. So first Bohr orbit n equal to 1 and Z equal to 3 lithium. ताले V1 नहीं परिवा को V1 is 2.188 into 10 to the 6 into 3 that is equal to x. तापर कौन देची? Then calculate the speed of electron in the second Bohr orbit of beryllium 3 plus. So V2 equal to calculate करियर अच्छी. So second Bohr orbit means N2 equal to 2 and Z equal to 4. So এটা कौन लिखिबा? Now V2 equal to 2.188 into 10 to the power 6 Z 4 by 2. 4 by 2. That is 2.188 into 10 to the 6 into 2. Okay. So what is V1 upon V2? That is equal to, you can write V1 upon V2, that is 3 by 2, that is x x by किसी factor number. So 3 by 2, 1 second, 3 by 2 or V2 equal to 2 by 3 into V1, that is 2 by 3 x. This is the answer. Note down. Then I hope all of the writing. If you have completed, then you can leave the class. Other kaହାର କିଛି doubt ଅଛି, then write in the chat box. The ତମର complete ହେଇଗଲାଣି, you can leave the class. Other students, after writing, then all of you have written. Okay. If you have written, then you can leave the class.